This will be the video for section 1.4, part 1. Today we're starting polynomials. So a polynomial is defined as an expression of the form, all of this that looks really crazy, but all that that's saying is you're going to have a coefficient, a sub n, so any number here, and then your variable x to some power n, so this would be your first term, plus some other term that has a coefficient a sub n minus 1, x to the n minus 1, and so on. So let's just, because this looks a little abstract, let's pick a number for n, like 3. So that would be a sub 3 x cubed plus a sub n minus 1 would be a 2, 3 minus 1 is 2, x 2 squared, plus, plugging in 3 here, a sub 3 minus 2 is 1, x cubed, 3 minus 2 is 1, so a to the x to the 1, plus dot dot dot, and then it goes all the way until you get a 0. Well, my next one, if I continue that pattern, decreasing this number by 1, I would get a sub 0, and then x to the 0. Well, anything to the 0 is 1, so you don't really need that last guy. So these a's, they could be any number, so this could be like 2x cubed plus 5x squared plus 2x minus 6. So that's an example of a polynomial, and that's what this definition up here is saying. Now it does say something kind of important right here. It says where a sub n can not equal 0, so this first coefficient can't be 0, and n is a non-negative integer. N is a non-negative integer. All right, so think about that, and then we've got a note here. Any variable may be used and there may be multiple variables present. So it doesn't have to be x, it could be y, it could be m, it could be anything, and actually there could be multiple variables present and it would still be a polynomial. All right, so we've got a little question here I want y'all to think about. It says, is it possible to have a variable in the denominator? So for a polynomial, is it possible to have a variable in the denominator? What do you think? And maybe refer back to this definition. So the key here is that it says n is non-negative. So if n has to be positive, then all of these exponents are also going to be positive. So it's going to be x to some positive number like 3, x to another positive number, and so on. So your n cannot be negative, which means all of your exponents are going to be positive. And the only way you could get a variable in the denominator, according to this definition, would be if you had a negative exponent like that, because that would be 1 over x squared. So you would have a variable in the denominator. But since n is not allowed to be negative, you can't have a variable in the denominator. So we would say no, because of that reason there, n has to be positive. So that's kind of a just a kind of a critical thinking challenge question, as well as this next one. Is it possible to have a fractional exponent? Can we have one of our exponents be a fraction in a polynomial? So again, if you look at the definition, it says n is a non-negative integer. Integer means a positive or a negative whole number. So no, it can't be a fraction because n must be an integer. And integers are not fractions. All right, so here's an example of a polynomial. And we've got a few definitions that we want to write down. First, we have term of a polynomial. A term is just the product of numbers and variables. So each of these guys are terms. We have 4 terms in that polynomial. The constant term is the term without a variable. So that would be 23. That's your constant term. All right. The degree of a term is determined by the exponent on the variable. The exponent on the variable is the degree of that term. The degree of a polynomial is the largest degree of the polynomial. So whatever the largest exponent is. The largest or highest degree of any term. Okay, so let's look back at our polynomial up here, our example. So the degree of this first term is 3 because the exponent's 3. And 2 for the next one, 1, and then 0, that's your constant term. The degree of the polynomial is the highest degree, and so that would be 3. The degree here is 3. Standard form. What is standard form? That's when you write the polynomial in order of the degree. So you're writing it so that the highest degree comes first and then it just goes down from there. And that's actually how it's already written up there. We've got the degree 3, 2, 1, 0. So that is standard form for a polynomial. The leading coefficient is exactly what it sounds like. Once your polynomial is in standard form, the leading coefficient is the first coefficient. Okay, so it'll be 2 in this case. All right. So let's look at some examples. We want to write the polynomial in standard form and then identify the degree and the leading coefficient. So on number 1, writing this in standard form, I want to put this term that has x to the 4th first, because that's the highest degree that I see. 4. It's the highest power. Then I'll go to 3x squared, so plus 3x squared. Then over to my x, and then I'll have minus 2 at the end. That constant term will always go last. Identify the degree. The degree of this polynomial is 4. And the leading coefficient is 5. All right, number 2, try writing that in standard form. make sure that that negative or that minus in front of the t cubed does stay with that term. So even if you rearrange it, that negative is going to go in the front. So the degree is 3, and the leading coefficient is -1. That's a -1 right there. All right, moving on to our next page. We are going to add and subtract polynomials. So my directions say polynomials are added by adding coefficients of like terms and subtracted by subtracting coefficients of like terms. So you want to just add and subtract like terms. It's easy enough. Let's look at A. I've got 2y to the 4th, and over here in my other polynomial, I've got 4y to the 4th. So I can combine those. It's going to be 6y to the 4th. Keep that exponent the same. Just add the coefficients. Now I've got minus 3y squared plus 7y squared gives me plus 4y squared. And lastly, I've got plus y plus 6y. That gives me plus 7y. Okay, notice my exponents did not change. I just added the coefficients. Okay, now B. Since this one's minus, I want you to go ahead and distribute that negative. That negative needs to go, that minus needs to be distributed to all 3 terms. So that will become -3m cubed minus 8m squared plus 4 minus m cubed minus 7m squared plus 3. So you need to make sure that negative goes to all 3 terms, and then we'll combine like terms. Okay, so combining these m cubeds, that's -4m cubed. Got m squares. -8 minus 7 is -15 m squared. And then plus 4 plus 3 gives me plus 7. So that is how you subtract polynomials. On part C, now we have multiple variables involved. So in order for them to be like terms, when there are multiple variables, they have to have the same variables with the same exponents. So that means right here, r cubed s6, I can only add that to something else that has r cubed s to the 6th. So right here I can combine those two. That'll be 35 r cubed s to the 6th. And then I can combine r to the 6 s cubed with r to the 6 s cubed. Okay, so we can combine those two, gives us minus 10 r6 s cubed. So same variables with the same exponents. Okay, moving on to multiplying polynomials. This first one we need to distribute. We've got this is called a monomial right here. It has one term, and we want to distribute that to all 3 terms of this polynomial. So 5 times 4, you're just multiplying those two, just like we did when we did properties of exponents. Multiply the coefficients, that's 20. Add the exponents, so y to the 2 plus 4, which is 6. Multiply coefficients, add exponents. It's plus 35. Y to the 2 plus 2 is 4. 30. Y to the 2 plus 1 is 3. Okay, on B we need to actually FOIL. We've got a binomial, 2 terms, times a binomial. We need to FOIL. So, FOIL is really repeated distribution, it just means you need to distribute the 7x to both terms. And then we will distribute the 3 to both terms. That's all FOIL is. It's just distributing multiple times. Okay, so distributing the 7x, I get 28x squared. And then to the negative 5, I get negative 35x. Then moving on to the 3, I've got plus 12x. And then minus 15. I'm going to combine like terms here to simplify, and we're done. All right, looking at C, we've got distribution, and then we're going to have to FOIL. Okay, so first, just take this one step at a time. We're going to distribute the 2t to both terms. So that should give us 8t squared minus 10t. Rewrite that second polynomial. Okay, now second step, we're going to FOIL here. We're going to distribute each of these terms to all 3 of these terms. So starting with the 8t squared, distributing that, I get 24t to the 4th minus 16t cubed. Last term gives me plus 56t squared. All right, now doing the minus 10t, that gives me negative 30t cubed plus 20t squared minus 70t. Okay, so you're distributing both of those to all 3 of these. And lastly, we want to combine like terms. So I don't have any other t to the 4ths, so 24t to the 4th will stay. I've got, if you want to cross those out as you go, I know that helped me when I was in high school. Just make sure that you don't forget any terms. So we've taken care of that one. Now looking at t cubed, I've got that and that I can combine. That gives me minus 46t cubed. Then I've got my t squares. That gives me plus 76t squared. And I'm left with minus 70t. All right, this will be our last problem today. We're going to be FOILing 2 trinomials. So distributing each of these 3 to each of these 3. So that's going to be 9 different multiplications. So start with a 3m squared. Distribute that. We've got 3m to the 4th. All right, to the next guy. That gives me 12m cubed. Remember, we're adding those exponents, so 2 plus 1 is 3. And to the last one, that gives me 18m squared. Okay, now I'm going to do that middle term, that minus 2m, to all 3. So that gives me minus 2m cubed minus 8m squared minus 12m. If you run out of space, you can go to the next line. So that I'm going to do that right here. I'm going to go plus 5m squared plus 20m plus 30. Okay, so I did all 3 of these to all 3 of these in the second one. Now we're going to combine like terms. So I don't have any other m to the fourths, so that's just 3m to the fourth. Now looking at my m cubes, there's m cubed. That's plus 10m cubed. My m squareds, got 3 of them. Those combine to give you plus 15m squared. My m's, I've got negative 12 plus 20 is 8. And lastly, plus 30, that constant term. Oops, I said 30 and I wrote 13. 30.